Here's a video on the in-class examples for section 2.7. In the first example, we want to solve the inequality 4 times the quantity x minus 5 plus 3x less than 10x plus 1. So we're going to start off by distributing the 4 to the x and to the negative 5. So this gives us 4x minus 20. Then we still have the plus 3x, that is less than 10x plus 1. Once we distribute, the next step is to combine our like terms. So if we combine 4x and 3x, this gives you 7x minus 20, and that is less than 10x plus 1. Now we have to move all the variables to one side. And remember that in inequalities, the variables, they always move left. In equations, we can move them either side, but for inequalities, the variables always move left. So we are going to subtract 10x from each side. Okay, once we do, we get a negative 3x minus 20. That's less than 1. So the constants, they move to the right. Since the variables move left, they always have to be on opposite sides. So we are going to add 20 to each side. And then this gives us negative 3x is less than 21. And then finally, the opposite of multiplying by negative 3, let me write that a little bit higher. We got negative 3x less than 21. The inverse of multiplying by negative 3 is divide by negative 3. So we divide both sides by negative 3. And once we do, we're going to get x is greater than negative 7. Now the inequality flips because we divided both sides by a negative. Anytime we divide both sides by a negative, the inequality does reverse or flip. Okay, so now we have to graph this. So once you solve it, you have to graph it. And my number line, it doesn't have a negative 7. So I'm just going to extend that and add a negative 7 here. Okay, so x greater than negative 7. Greater than, so we want the set of all numbers that are greater than negative 7. So first question we ask ourselves is, do we have a parentheses or a bracket? In MyOpenMath, you will use an open circle and a closed circle. So in this case, because it's a greater than, I'm going to have an open circle or a parentheses. Okay, so I'll use a parentheses here. Now the numbers are greater than negative 7, so they're getting bigger and bigger and bigger and bigger and bigger. And when you have a greater than, it's going to go to positive infinity. The numbers are getting infinitely big. So our solution set looks like this. The set of all numbers that are greater than negative 7. So they're approaching positive infinity. In interval notation, the lowest value in our solution set is negative 7, and the numbers are approaching infinity, so our solution set is going to be negative 7, comma, infinity. Okay, the next in-class example was this one here. We had negative 5 less than x plus 1 less than or equal to 8. So this inequality is sandwiched in between two values. So we're going to subtract 1 from the middle, and that means we subtract 1 from each side. Okay, so we have negative 6 less than x, that's less than or equal to 7. Now here's what this means. This means that x is the set of all numbers. X is the set of all numbers between negative 6 and 7. That's what this solution means in words. X is the set of all numbers in between negative 6 and 7. So on one side, we have negative 6. And that has a parentheses on it, or an open circle, because of the less than sign. There's no equal to. So that number, negative 6, is not included. On the other side, we have a 7 that has a bracket because we do have an equal to. And our solution set is a set of all numbers that are in between negative 6 and 7. So whenever x is sandwiched in between two numbers, we have a lower value, an upper value, and our solution set is all the numbers in between those two values. In interval notation, we have a parentheses negative 6 and a bracket positive 7. I'm going to show you guys another way to look at this. Our inequality is negative 6 less than x less than or equal to 7. Let's say that I just take the left part of this inequality, negative 6 less than x. Now we know that our variable needs to be on the left side. It can't be on the right. So we're going to take this and we're going to flip the whole thing to make the variable go on the left. So this says x greater than negative 6. And now if I ignore the left part and just take the right part, we have x less than or equal to positive 7. So what we have is a set of numbers that are greater than negative 6, which is why we go to the right of negative 6, and less than or equal to positive 7, which is why we go to the left of positive 7, and they intersect in the middle. So the solution set is all the numbers in between negative 6 and 7. But in general, anytime you have x sandwiched in between two values, this is going to be your solution. Okay, the next class example was the absolute value of 3x minus 9 plus 5 is less than or equal to 23. So first we need to get the absolute value by itself, which means we are going to subtract 5 from the middle and subtract 5 from the right. So we have the absolute value of 3x minus 9, and that is less than or equal to 18. Now remember, the setup when you have this case, when you have the absolute value of a less than, or in this case less than or equal to u, the setup is going to be like this: negative u less than or equal to a, which is less than or equal to positive u. That's going to be our setup. So in this case, our u value is 18. So when we set this up, we have negative 18 less than or equal to 3x minus 9, and that's less than or equal to positive 18. And that's when our inequality is a less than or equal to. So when we have a less than or equal to, we get the sandwich case. And the way I remember that is my inequality is less than, and so that's going to be a sandwich. So if I solve this, I need to add 9 to the middle, which means I add 9 to the right, and I add 9 to the left. So this gives me negative 9 less than or equal to 3x, which is less than or equal to 27. Then I divide everything by 3. So I divide the middle by 3, which means I divide the right and the left by 3. And my solution set, which I'll write over here, negative 9 over 3 is negative 3. That's going to be less than or equal to x, which is going to be less than or equal to 9. So now we know that x is a set of all numbers between negative 3 and 9. Our solution set is the set of all numbers, and notice that they're in between negative 3 and positive 9. So when we graph this, here's what our graph looks like. On one side, we have a negative 3, and that's going to be in a bracket because we have a less than or equal to. On the other side, we have a positive 9, and x is sandwiched in between. So our solution set is going to be the set of all values that are in between negative 3 and positive 9. In interval notation, the lowest value in our solution set is a negative 3. Our highest value is a positive 9, and that is our answer.